Welcome to Math Essentials Vector Calculus. Today we are going to discuss about the dot product. The purpose of this video is to define what is dot or a scalar product and know how to calculate it. Then we introduce some applications of this dot product. So what is a dot product? It is a measure of the alignment of two given vectors, and it tells actually us that how much one vector lies along the direction of the other vector. Let's learn together how to calculate the dot product. First, we'll start with analytical calculation. We are given two vectors in the three-dimensional. Each of them have some component in A1, A2, and A3, which are the unit vector in this specific three-dimensional system. And let's revise together in fast. We have actually three coordinate system. The first one is Cartesian. In Cartesian, we have I, J, K. This is the unit vector there. We have cylindrical and we have spherical. In cylindrical, we have rho, phi, and k as the unit vectors. And finally, in the spherical, we have r, theta, and phi as the unit vector. So what you see here is a scalar value, and what you see here is just unit vector. Now, if we want to calculate the dot product, what we will do, simply, so A dot B, this is how we define it. We put small dot between the vectors. We take the first component, multiply to each other, A1, B1 plus A2, B2, the second component multiplied by the second component, plus A3, B3. Finally, we need to note one important issue, that the result of the dot product will be always a scalar value. This means if we have a system and we named it dot product, and we have two inputs, A1 and A and P, then our output is A dot B, and we have here vectors, and we have here a scalar value. The next step is to learn how to calculate the dot product geometrically. So this will happen by calculating first what's called the magnitude of A and magnitude of P with the knowledge of the angle between them, alpha, taking cosine alpha, then multiply A magnitude, B magnitude, cosine alpha, then we get the value of dot product. This is angle alpha, is just the angle between A and P. Now we move to the application. The first one is magnitude. So if we actually multiplied one vector by itself, dot product, you will find that the result is just what we call squared magnitude. This means that the magnitude of any vector is simply the root of the self dot product of this vector. Finally, the magnitude represents size or intensity of a given vector. Now we move to the second application, which is the projection. A projection of one vector A on a vector P is simply the scalar component of vector A on the direction of B. Projection of A in terms of B is simply the vector A multiplied by the unit vector in the direction of B, which is simply the P divided by P magnitude. So this is what we are explaining. We just analyzed A in two directions. This direction, a direction perpendicular to B, we can say maybe B perpendicular, and in the direction of P. Of course, in both cases, we need to divide by the magnitude, such as it is a unit vector. Then we multiplied only because we need the magnitude in the direction of B only. So we multiply A itself by the unit vector in the direction of B. So finally, you will find that this value, scalar value, is your projection. The third application today is the mechanical work. Mechanical work is the energy transferred to or from an object by a force that causes a displacement. It can be calculated as W equal to, of course, W is a scalar, equal to vector of F dot product vector of D. And this can be simplified geometrically as magnitude of F magnitude of D cosine alpha, and alpha is the angle between them. Let's have an example. If you are pulling or pushing a block on a surface, so assume I'm pulling and my target direction is this one, this my displacement vector D, but unfortunately I applied the force with some angle with displacement vector D. What will happen? I'll waste some effort in this direction, because if I analyze my F, this is my F, I'll analyze it here. So this is F parallel, for example, and this is F perpendicular, and unfortunately only F parallel will contribute to the work, which actually this is here. If you come back here, your F parallel is simply F cosine alpha. This is simply my F parallel. So in summary, only the component of force along displacement contribute to the work. So what we have learned today, we have learned about the dot product, which is an alignment measure, and we have learned also how to calculate it, and then we have taken some example such as a magnitude, projection, and work. Thank you.